All right, so we started discussing moles and we talked about how stoichiometry and mole conversion helps us do the calculations. Now, how do we know if a question is of stoichiometry or if a question is of moles? The idea is simple. If you have just one substance that is being discussed, then that is a mole conversion question. And if you have a question which talks about two substances, then that is a stoichiometry problem. Let's take an example. Yesterday, we talked about a question. I'll just copy that question here. That what is the mass of 11.5 dm cube oxygen at room temperature and pressure? Now, what do you think? Is this a mole conversion question or a stoichiometry problem?
There is a mole conversion, like it really
Yes.
has one substance.
Yes, shabash. So it is a mole conversion question because it only talks about one substance. Okay. So we will take this to be our mole conversion problem. And how do we solve it? We'll say that 1 mole is mr grams, and in oxygen's case, that is 32. Why is it 32? Because oxygen will always take it to be O2. Unless they say it is oxygen atoms, we will take it to be O2. And what is the volume? 24 dm cube. It's a gas. So 11.5 dm cube will take x grams. Now you cross multiply them. 32 times 11.5 is equal to 24x. So 24 divides here, and there you go. That's our answer. Whatever that comes out to be. Can you calculate, please? 15.3 grams. And that's my answer. Now let's take another question. Now this question is about stoichiometry. So the question says, how much, what mass that completely burns in 11.5 dm cube oxygen? Now we know that this is a stoichiometry problem. Can anybody confirm why? How do we know that this is a stoichiometry problem?
Sir, because there are ethanol and oxygen. There are two substances it's talking
Very
about.
good. So there are two substances that it talks about. So it is indeed a question of stoichiometry. So we'll first make an equation for this. So the equation comes out to be, okay, so this is the balanced equation. Does everybody understand how I balanced it? So basically I had 2 carbons, so I put 2 here, and I had 6 hydrogens, so I put 3 times 2, 6 here, or in other words, 6 divided by 2, 3 here. Then how much oxygen I had? 2 times 2 is 4, and 3 times 1 is 3. I add them, I get 7. Out of that 7, 1 is over here, so the remaining 6 should be here. So 6 over 2, 3 again. So that's what I have. Okay. So the question is mass of ethanol when volume of oxygen is given. So I'll just copy that part as I told you yesterday. Copy this portion. So C2H5 OH and 3O2. I have MR of this. So this is the mass and this is the volume. So MR of ethanol is 46. So 46 grams reacts with 3 times 24 dm cube of this. Why 24? Because it is volume. And I have 11.5 available. So it's going to react with X. Cross multiply. And I'll get 46 times 11.5 is equal to 3 into 24x. And now I'll just solve it. Okay. So this is a stoichiometry problem. And I've solved it. All right. So that is how you solve this. And I've shared 3 worksheets with you. Moles 1 worksheet is basically what we talked about earlier in the month. And this is percentage mass and MR and all that. So you should be able to calculate it, do it tomorrow. Moles 2 and moles 3, that is what I would like us to focus on today. All right. Now, before we do that, there's another concept that I want to talk about, and that is limiting reactant. What is a limiting reactant question? The idea of a limiting reactant is that the reactant that runs out first, the reactant that runs out first That's your limiting reactant. Kyun? Because this will limit how much product you can get. So there are two ways of solving this. First of all, how do you identify that this question is a limiting reactant question? That's easy. You will get information of two or more reactant. That is what they will give to you, that you already have the information of two or more reactants available. And that will tell us that, oh, this is a limiting reactant question. All right, so we were working on this worksheet yesterday. For example, okay, let's look at this question. Can anybody tell me how we know that this is a limiting reactant question? We have the information of butanoic acid as well as information of sodium carbonate. And they're both reactants, butanoic acid and sodium carbonate. दोनों reactants के बारे में हमें कुछ ना कुछ उसने बताया हुआ है. So this means it is a limiting reactant question. अब लिमिटिंग रिएक्टेंट क्वेश्चन को सॉल्व करने के हमारे पास दो तरीके हैं. एक तरीका मैंने खुद ही बनाया है, तो आई विल शो दैट टू यू. एंड द सेकंड मेथड इज व्हाट इज यूजुअली टॉट इन स्कूल्स. बोथ ऑफ देम आर equally good and you choose what you're comfortable with. Okay, so the first method that I made is called, I call it least product method. Basically, the idea is you pick this and you compare it with any one product. Could be carbon dioxide, could be water, could be this. Similarly, then you pick this and you compare it with the same product here. So let me show how I will use this. So let's say I take the first product compound 2C3H7COOH and I compare it with carbon dioxide. I want to know how much carbon dioxide will 5.28 of this produce. So for that, obviously, this is the mass, this is the carbon dioxide, can be volume, can be moles, can be mass. It's totally my choice. Let's say I pick volume. So now this is telling me that 2 of this produces 1 of that. I'll put the standard values. So 2 moles of this. What is the mass of 1 mole? The MR of this thing is 88. So iska matlab hai 2 times 88 grams produces, what is the volume of 1 mole? 24 dm cube. So I have a relation here that 2 times 88 of this produces 24 dm cube of that. Okay. Now 5.28 will produce X. I have used this information. I've completely ignored this because abhi main sirf isko aur isko compare kar raha hu. I could have compared it with this. मेरी मर्जी है, मैंने कार्बन डाइऑक्साइड पिक कर लिया. Alright, so I cross multiply, I get X equals 2 times 88. X is equal to 5.28 times 24. X is going to be 5.28 times 24 over 2 times 88. Okay, does anybody have a calculator? Okay, so I got 0.72 dm cube. So basically मैं ये कह रहा हूँ कि अगर मेरे पास 5.28 grams butanoic acid है, तो it is enough to produce 0.72. ठीक है. Now I will compare it to the other one. So I'll take same thing. I have sodium carbonate now, and I'll compare it with again volume of carbon dioxide. अच्छा, अब ये चीज है concentration, यानी कि ये volume, ये है volume. तो volume वाले questions को मैंने कल आपको बताया था कि हम कैसे solve करते हैं. हम इसके सिर्फ moles को compare करते हैं, क्योंकि volume है ना, solution है. So ये तो और आसान है, क्योंकि equation में मुझे पता है 1 mole of this produces 1 mole of that, which is 24 dm cube. यानी कि ये 1 mole होगा तो 24 dm cube कार्बन डाइऑक्साइड प्रोड्यूस होगी. अच्छा, आपके पास कितने मोल्स हैं? हम कैलकुलेट करते हैं. N इक्वल टू CV. C कितना है? 0.5. N कितना है? वॉल्यूम कितनी है? 56 डिवाइडेड बाय 1000 cm क्यूब. अगर बहुत ज्यादा बड़े नंबर्स लग रहे हैं तो जस्ट रिमेंबर द फॉर्मूला इज N इक्वल टू CV फॉर सॉल्यूशंस. सो अब मैं वैल्यूज लिखूंगा. दिस विल प्रोड्यूस X. सो अगेन क्रॉस मल्टीप्लाई. X is going to be equal to 24 times 0.5 times 56 over 1000. This gives me 24 times 0.5 times 56 over 1000, 0.672. So देखें which product is less. The question is least product method. So clearly the amount of gas produced by sodium carbonate is less. तो जो less produce कर रहा है वो limiting reactant है. तो जो ज्यादा produce कर रहा है वो क्या है? In excess. ये word in excess. तो जो कम produce कर रहा है वो limiting reactant है. जो हमारे पास clearly sodium carbonate है क्योंकि वो 0.672 produce कर रहा है while the other one is producing a higher value. So we will say that this shows that so butanoic acid is in excess. तो ये आपका पहला method है. What is the other method? The other method is called predicted value method. Again, ये नाम मैंने खुद ही दिए हैं. Okay, predicted value. How does this work? Predicted value method में you ignore any one value. या आप इसको ignore कर दें या आप इसको ignore कर दें. और अब आपने let's suppose ये value ignore कर दिया ना, अब आपने ये value predict करनी है अपनी calculation से. ठीक है? Let me show you. मैंने इन दोनों को कंपेयर करना है. मैंने इसको इग्नोर कर दिया है और अब मैं इसको यूज करके इसकी वैल्यू प्रिडिक्ट करूंगा. So I'll just copy this 2C3H7COOH और दूसरी साइड पे Na2CO3 है. So इसके मास गिवन है, इसके मोल्स होंगे. So 2 times 88 grams और 1 mole. ठीक है. अच्छा जी. तो मेरे पास ये है इसके मोल्स N equal to CV 56 over 1000 into 0.5 और इसकी वैल्यू मैं प्रिडिक्ट करूंगा कि ये ना जाने कितनी. So let me cross multiply again. So 2 into 88 into 56 over 1000 into 0.5 will give me X. So I get 4.93 grams. This is my predicted value. कि अगर इतने moles के साथ complete reaction करें, then I need this many grams. Is my predicted value less or more? The value is less. That means I have extra butanoic acid. So we'll say that we have more 5.2 jitni bhi wo value is more than 4.93. So butanoic acid is in excess. Clear? Because my predicted value मेरे पास उससे ज्यादा अवेलेबल है तो एक्सेस में, और अगर predicted value कम होती और ज्यादा होती और अवेलेबल कम होता तो वो लिमिटिंग है कि मेरे पास उतना है ही नहीं जितनी मेरी predicted value. So we have two methods of doing the questions of limiting reactant. और इनको क्वेश्चन को कैसे पता चलेगा कि लिमिटिंग रिएक्टेंट का क्वेश्चन है? हमें क्वेश्चन स्टेटमेंट में दो चीजों के बारे में गिवन होगा, दो रिएक्टेंट्स के बारे में इंफॉर्मेशन गिवन होगी, तो ये लिमिटिंग रिएक्टेंट क्वेश्चन. ऑलराइट, लेट्स ट्राई अनदर क्वेश्चन. ये तो बड़े आसान सवाल थे सारे, इनमें तो कोई लिमिटिंग रिएक्टेंट वाला था ही नहीं. ओके, हियर आई हैव अ क्वेश्चन. ओके, सो द क्वेश्चन इज, फर्स्ट ऑफ ऑल, हाउ डू यू नो this is a question of limiting reactant? Because they have given us information of this as well as this. It's a pretty straightforward question. So let's solve it. सबसे पहले equation बनानी होगी. So Al2O3 reacts with magnesium, produces Al plus MgO. Balance कर लेते हैं. Okay, balance. Okay, so we want to figure out mass of aluminum formed. तो हम लीस्ट प्रोडक्ट मेथड भी कर सकते हैं और हम प्रिडिक्टेड वैल्यू मेथड भी कर सकते हैं, बट आई विल प्रेफर द लीस्ट प्रोडक्ट मेथड है क्योंकि हमें आंसर एंड पे प्रोडक्ट का ही बताना है, मास ऑफ एल्यूमिनियम ही बताना है. तो व्हाई नॉट जस्ट स्टार्ट फ्रॉम द गेट गो. ओके, सो आई एम यूजिंग द लीस्ट प्रोडक्ट मेथड नाउ. हाउ डू आई डू इट? आई विल टेक Al2O3 and I'll find out how much aluminum does it make. So the MR of Al2O3 is going to be 102, 48 plus 56, 102. So 102 grams of this produces 2 times 27 grams of this. So 25.5 grams will produce X. Cross multiply, and we get this. So this tells me that this should produce 13.5 grams. Okay, let's try the other one. So 3 times 24 grams produces 2 times 27 grams. 1 mole की value देनी है ना, वो ये आ गई. So I have 50 grams. So it will produce X. Cross multiply, 3 times 24, X is equal to 2 times 27 times 50. This will divide it. And that's going to give me 37.5 grams. Clearly, this is limiting reactant. And this will be my final answer. Because limiting reactant decides how much product is made. So least product. अच्छा, हम predicted value को यूज करते हैं. हम predicted value से पहले पता करेंगे कौन सा limiting reactant है और फिर हम उसको यूज करेंगे to find the aluminum. So let's do that. Second method, predicted value. मैंने किसी एक को इग्नोर करना है, या इसको इग्नोर करना है या इसको इग्नोर करना है. लेट्स से मैं मैग्नीशियम को इग्नोर कर देता हूँ. सो Al2O3 3 mg, ठीक है. Again 102 grams will produce 3 times 24 grams. I have 25.5 of this, so this will produce X. That my predicted value is के इसके साथ X का reaction होगा. So 102 times X is equal to 3 times 24 times 25.5. X will be this whole thing divided by 102. So put it in a calculator. मेरे पास आती है 12. This is my predicted value. Do I have more than this? Of course. I have 50 grams. So clearly, this is in excess. This will be limiting. So अब जब मुझे this shows that magnesium is in excess. So अब जब मुझे पता चल गया है तो अब मैं aluminum वाला क्वेश्चन सॉल्व कर लूंगा. तो Al2O3 produces 2 aluminum. और अब मेरा स्ट्रेट फॉरवर्ड क्वेश्चन है कि मैग्नीशियम एक्सेस में उसको इग्नोर करो, Al2O3 से एल्यूमिनियम कैलकुलेट कर लो. सो 102 इसके 1 मोल की वैल्यू है. 102 grams will produce 2 times 27 grams. So 25.5 will produce X. Cross multiply, 102X is equal to 2 times 27 times 25.5 divided by 102 हो जाएगा क्योंकि ये इधर से डिवाइड करेगा. So my answer will simply be 13.5 grams. And that's actually what I had earlier as well. Do you see it? Same answer. It all comes down to what you're more comfortable with. Okay. Can we use it for solutions? Of course we can use it for solutions. Let's do a question. Okay. The question says, all right, now let's do this question. अब इसमें भी हम least product method करेंगे क्योंकि what mass of water पूछा है उसने हमसे. So 2NaOH produces 2 water, ये एक ये होगा, और H2SO4 produces 2 water, एक ये होगा. Okay, least product method use कर रहा हूँ. This is both of them are solutions. तो इसका मतलब है मुझे दोनों के moles चाहिए. तो if you are not comfortable with weird numbers, you can just choose the moles first. ठीक है कि आप पहले moles calculate कर लो. सोडियम हाइड्रोक्साइड के moles हैं 50/1000 n equal to CV formula into 0.5. तो वो होगा 0.025. और इसी तरह H2SO4 के moles अगर आप कैलकुलेट करें तो वो आते हैं 28/1000 into 0.62, 0.0174. ठीक है. The equation says 2 moles of this produces 2 times 18 grams of this. Grams क्यों ले रहा हूं? क्योंकि उसका उसने mass मांगा मुझसे. So 0.025 will produce x. So 2x is equal to 2 times 18 times 0.025. ये 2 cancel हो गए. So I'm gonna get 0.45 grams. एक ही option है. And over there, 1 mole produces 2 times 18 grams. I have 0.0174 moles. So that will produce x grams. X is going to be 0.0174 times 2 times 18. So that is 0.626 grams. Clearly, this one is less. So we will say that sodium hydroxide is the limiting reactant. और जब limiting reactant होता है वो decide करता है कि कितना produce होगा. So 0.45 grams water produce होगा. पहली तो ये बात होगी. Now the next question is find the amount of energy released. ये बड़ा अजीब सा सवाल है. ये हमें कैसे पता चलेगा? Let's go back to the question. उसने बोला ये इक्वेशन है और ये डेल्टा एच है -57 किलो जूल्स. ठीक है, यानी 1 मोल वाटर प्रोड्यूस हो तो -57 किलो जूल्स प्रोड्यूस होता है. यहां पर है 2 मोल वाटर प्रोड्यूस हो रहा. तो मुझे बताएं अगर 1 मोल प्रोड्यूस हो तो -57 है, 2 मोल्स पे कितना होगा? सो हम कह सकते हैं कि अच्छा mass of water अगर 1 मोल हो तो वो होता है 18 ग्राम्स और वो देता है -57 किलो जूल्स. हमारे पास है 0.45 grams, so it will produce x kilojoules. So I'll just cross multiply. So x is going to be 18x is -57 into 0.45. X is going to be -57 into 0.45 over 18. And I'll just solve it. 1.43 kilojoules. That is how much is released. ठीक है? So there you go. Now we're able to do all the questions that require moles. But of course, you're only as good as you practice. I've shared 4 worksheets with you now. Please attempt moles 2 and 3 जो आज भेजी है वो तो जरूर करें, and moles 1 आप बाद में कर लेना चाहे. Don't attempt MCQs अभी. क्यों? MCQs will require some shortcuts because in theory paper in ATP we are not constrained with time. In MCQs we need to focus on saving time, तो उसके लिए हमें shortcuts चाहिए. वो shortcuts हम कब करेंगे? जब हमें theory पे पूरी grip होगी. So tomorrow I'll teach you the shortcuts. So make sure that you take some time out tonight or tomorrow and solve the worksheets, exhaust them. All right then. See you tomorrow. Allah Hafiz.